Good morning, Mandala. I am B. Rahul from CSCC section. Today's my concept video topic is normal distribution properties. Let us know what is normal distribution. Introduction. A normal distribution, sometimes called the bell curve, is a distribution that occurs naturally in many situations. For example, the bell curve is seen in tests like the SAT and GRE. The bulk of the students will score the average C, while smaller number of students will score A, B, or D. An even smaller percentage of students scores an F or an A. This creates a distribution that resembles a bell, hence the nickname. The bell curve is symmetrical. Half of the data will fall to the left of the mean, half will fall to the right. The exactly how the normal distribution curve looks. See, on the x-axis there is f of x, on the y-axis f of x, and on the x-axis x. You can see the increasing and decreasing of the curve. Changing mu shifts the distribution left or right. Changing sigma increases the decreases the spread. The normal distribution has mathematical function PDF. F of x equals to 1 by sigma under root 2 pi into e to the power of minus 1 by 2 into x minus q by sigma whole square. Note constant. Pi equals to 3.14159, e equals to 2.71828. Here's here's this is the bell spread curve with different centers and spread differing on mu and sigma. The normal distribution has mathematical function PDF. F of x, the normal distribution. The normal distribution PDF. It is a probability function, so no matter how the value of mu and sigma must interact to 1. See, minus infinity to infinity 1 by under root sigma under root 2 pi e to the power of minus 1 by 2 x minus mu by sigma whole square dx equals to 1. E of x equals to mu, that equals to integration of plus infinity to minus infinity x 1 by under root 2 pi sigma into e to the power of minus 1 by 2 x minus mu by sigma whole square dx, where x equals to sigma square that equals to derivation of plus infinity to minus infinity x square into 1 by under root pi by under root 2 pi into e 1 by 2 x minus mu by sigma whole square dx minus mu square. Standard deviation of x equals to sigma. Here's the derived by its mean and standard deviation. E of x, var x, and standard deviation. There are three different formulas: mu, mu square, and mu. Where it is comes to mu, you can see. Where it is sigma square, you can see. Where is sigma, you can see. Here are the three different formulas which we are using in normal distribution. The first formula is to find the average mean, and this is between standard deviation sigma. The var percentage is between sigma square. The beauty of normal curve is no matter what mu and sigma are, the area between mu and sigma at mu plus sigma is about 68%. The area between mu and 2 pi plus and mu plus 2 pi is about 95%. And the area between mu minus 3 sigma and mu plus 3 sigma is about 99.7%. Almost all values fall within three standard derivations. See, here comes the rules: 68 to 95 to 99.7. You can see the graph in three different colors: blue, green, red. You can see the graph in three different colors. Where you in the red, in the graph at the top of the graph, you can see 68% of the data is in red color. In green color, it is 95% of data. Where it comes to blue color, it is about 97.7% of the data. In the given 100%, 99.7% of the data is blue and 95% is green and the 68% is red. has it divided in these three types. See 68 to 95 to 99.7 rule in max term. Sigma plus mu minus sigma 1 by mu by 2 pi into e to the power of minus 1 by 2 x minus mu by sigma whole square dx equals to 68%. And where it comes to 95%, mu plus 2 pi mu minus 2 sigma mu plus 2 sigma derivation of mu minus 2 sigma 1 by under root 2 pi into sigma into e to the power of minus 1 by 2 x minus mu by sigma whole square. It gives dx equals to 95. 2 plus 3 pi under root 2 minus mu minus 3 pi sigma 1 by root 2 pi into minus 1 by 2 x minus mu by x square dx equals to 99.7%. We can see the three different values means percentage 68, 95, 99.7. It has three different formulas as we calculating in the max terms. See, when it comes to 68 you can see the formula. When it comes to 95% we can use this formula. Means when it comes to 99.7% we have to use this formula. Example, suppose a set scores roughly follows a normal distribution in US population of college bound students with range restricting 200 to 800. The average math sat is 500 and the student derivation of 50. Then 68 of students will score more than 40, 450 and 550. 95% will be between 400 and 600. 99.7% will be between 350 to 650 students. But what if would be the math SAT scores corresponding to the 90th percentile, that equals to 90 of the students are lower. P of x is less than or equal to q equals to 90. Formula q derivating 200 1 by 50 into 2 pi into e to the power of minus 1 by 2 x minus 500 by 50 whole square dx, that equals to 90. Solving for q, yx. The standard normal z universal currency. The formula for the standard normal probability density function is p of z, that equals to 1 by 1 into 2 pi dot 6 minus 1 by 2 z minus 0 by 1 whole square, that equals to 1 by under root 2 pi into e to the power of minus 1 by 2 z square. The standard normal distribution z. The standard normal distribution z. All the normal distributions can be converted into the standard normal curve by subtracting the mean and dividing by the standard deviation. Z equals to, here comes the formula. Somebody calculated all the integral for the standard normal and put them in a table. So we never have to integrate. Even better, computers now do all the integrations. Comparisons x and z units 100, 200, z 150 mu 0. Example. So you can see the example. For example, what the probability of getting a math SAT score of 575 or less? We have given the data. Z equals to 575 minus 500 by 50. That gives 1.5. A score 575 is 1.5 standard deviation above the mean. Given p is x less than or equals to 575, that equal to 575 integrating to 200 1 by 50 into under root 2 pi into e to the power of minus 1 by 2 x minus 500 by 50 whole square dx. It gives integration of 1.5 minus infinity minus 1 by under root 2 pi into e to the power of minus 1 by 2 z square dz yx. But to look up z equals to 1.5 in standard normal chart or enter into a SAS, no problem. Look at the probabilities in the standard normal table. By locating this table, we can calculate the values. What is the area of the left of z equals to 1.5 in the normal standard curve? It gives in the 1.5, and we have to choose this 0.01 in this column. Means we have to calculate rows and column by the given by getting the z value. Then we have to do where these 2 points are intersecting. That is the main area of the given curve. Area is 93.45 percentage. Normal probability in SS no null. Area equals to problem. Put the area run 0.933192798. And if you wanted to go to the other direction, i.e. from the area to the z scores collected and so called probit function data null. The probit p function gives up the z value and the corresponding to the left area of the p. For the normal curve, the profit function is also known as the inverse standard normal function. Proportions. The binomial distribution from the bias of the statistics from promotions. The promotion is just a binomial count divided by n. Here's come the example. If your sample is 200 cases and the find 60 smokers, x equals to 60, but abuse is proportion is 30. Statistics for promotion are similar to the binomial counters but differ by a factor of n. For binomial, for proportions, you can see formulas and derivations. P has standard for sample proportions. This differs by the factor of n. It all comes back to z. Static for the proportion is based on the normal distribution because the binomial can be approached as a normal if NP is greater than 5. Properties of a normal distribution. The mean, mode and median are equal. The curve is symmetric at the center around the mean mu. Exactly half of the values are to the left of the center and exactly half of the values are to the right. The total area falls under the curve is 1, the standard normal model. A standard normal model is under distribution with a mean of 0 and a standard deviation of 1. Thank you.